Hello and welcome to this course on working with data in Android. As an aspiring developer, you will need to be able to demonstrate a working knowledge of how Android applications communicate over the web. This course will help you advance your app development skills by introducing you to Android asynchronous programming techniques. You'll also get to experience concepts and practices of the industry standard Structured Query Language, or SQL, as you explore storing app data using a product called SQLite. A primary driver of app adoption is the ready availability of timely information. Perfectly functional apps will lose your interest if you cannot depend on them to instantly provide you with the data you need, when you need it. Your data requirement might be very specific, such as how close your taxi is or when your food order will arrive. Or it might be more global, such as when you want to hear about current world events or to research the best deals for a new mobile device. To satisfy the user's data requirements in your apps, it's vital to understand how Android apps can store and access files not only on a device's storage, but also from external online sources. In this Working with Data in Android course, you will expand your programming knowledge so that you can engineer better solutions when your Android applications communicate over the web. To do data development work with Android, you should have an advanced working knowledge of programming fundamentals, be familiar with the concepts of UX and UI design, and be able to create user interfaces in Android Studio. To assist with your learning, you will view and work on development tasks for the fictitious restaurant Little Lemon, where you will encounter many real-world scenarios. With your newly upskilled Android knowledge, you will work through these scenarios, overcoming challenges and implementing solutions. As your skill set grows, you will focus on many Android data concepts and tools, explore why you need them and how they are used. In this course introduction, you may encounter some new terms. Don't worry if you don't fully understand all of them. During the course, you'll explore these concepts in more detail, along with the core skills required to implement the concepts in your app development with Android. This course consists of 5 weeks of learning. By the end of this course, you should have acquired the skills and knowledge with the necessary tools to complete the end-of-course final project. Let's break down the content you will cover in each week of this Working with Data in Android course. Week 1 is your chance to get to know RESTful API development. The acronym API is short for Application Programming Interface, and REST means Representational State Transfer. REST provides guidelines that outline best practices for working with an API. After your studies this week, you will be able to explain different HTTP methods, status codes, and responses, identify the key characteristics, benefits, and uses of REST API, its states, and its resources, create routes with the correct naming conventions, explain the principles of authentication in a REST API, differentiate between authentication and authorization, and explain the API request lifecycle. Week 2 practices applying asynchronous programming techniques to query REST APIs and handle their responses using Kotlin and Android. You will advance your skills during this week to be able to explain concurrency in Kotlin, apply Kotlin coroutines in Android applications, and apply different concurrency patterns. Week 3 covers data in databases and accessing it using Structured Query Language, or SQL. After successfully completing this week, you will be able to explain what a database is and what its general uses are, explain how data is related in a database, differentiate between types of databases, and apply the syntax rules of SQL to use common SQL commands. In week 4, you'll work with SQLite in Android. After successfully completing this week, you'll be able to store simple data in Android using shared preferences, set up and query a SQLite database in Android, and connect data to app state. In this final week of the course, you will combine the concepts and skills gained from this course to complete the final app development project. The practical project work involves filtering and sorting an app's food menu and displaying it using SQLite. In addition, you'll get to reflect on the next steps in your learning journey. The Working with Data in Android course introduces you to many software engineering concepts to help you to better manage data in your Android apps. The important success factors for an app are not just about it looking well and functioning without error. They also include how well the app can deliver content to the user. Your programming approach to delivering content is based around creating and managing data solutions because these are vital components that ensure a successful app. I look forward to helping you advance your programming skills to the next level. Wishing you all the best on your Android learning journey.
By now, you know that HTTP stands for Hypertext Transfer Protocol, and that it's one of the most widely used communication protocols for transferring data across the Internet. Let's briefly refresh your memory of HTTP and HTTPS before diving into more complex topics. In this video, you will learn about how HTTP and HTTPS work, HTTP methods, HTTP requests and responses, and finally, HTTP status codes. When you browse web pages, view images, or submit a form, your data is transmitted using HTTP or a secured version of it, which is called HTTPS. But how does that transmission work for HTTP and HTTPS respectively? Communicating over HTTP requires at least two parts: the client, who requests some information, and the server who responds to this request and serves the content. HTTPS is the secured version of HTTP, which makes it better suited to instances where security is a concern. But let's find out how this works. With HTTPS, the client's computer encrypts data before it starts its journey to the server. The server then decrypts this client-side data and processes it. But the web server also encrypts the response data and sends the encrypted content back to your browser. Your browser then decrypts the response and displays it. Since the content is encrypted, it is more secure and very difficult to steal or retrieve information from it. For submitting sensitive data, like credit card information, it is always preferable to use HTTPS to make sure the data is secure. Now, let's move on to some common HTTP methods. HTTP methods are also called HTTP verbs. There are 5 methods commonly used when accessing content over HTTP. They are GET, which retrieves a resource; POST, used to send data to the server and then create a record; PUT, which updates the whole resource; PATCH, which you use to partially update a resource; and DELETE, which deletes a resource. Next are HTTP requests, which contain different types of information that a user's browser sends as encoded data. A typical HTTP request includes the following: HTTP version type, for example 1.1 or 2.0, URL or path, HTTP method, HTTP request headers, and an optional HTTP body. But what are the HTTP request headers and body again? Well, when you submit a form, like your username and password to sign into a website, that data is passed to the web server as the HTTP body as either a raw JSON string or a form URL encoded string. HTTP headers, on the other hand, are a core part of every HTTP request and may contain extra information that helps the server make some decisions on how to present the content. Examples of HTTP request headers are cookies, user agents, and referrers. After an HTTP request comes the HTTP response, which consists of information that the browser uses to properly display the content in the response body. The response contains the resource that was requested, and it also contains information like the length of the content type, and headers like cookies. It also contains e-tags, the time when the content was last modified, and finally, the response also contains some special numerical codes called HTTP status codes. You've surely seen these HTTP status codes, but you might not have known what they are for. Well, they are not really messages addressed to you, the user. They actually provide extra information to your browser about the resource. For example, if everything is okay, the server sends 200. You will not be aware of this because it doesn't even display in your browser. Or, if the requested content can't be found, the server responds with the 404 error code, which usually displays in the browser because there is nothing else to show. Here is a range of error codes and their meanings. 100 to 199 are used for informational messages. The codes from 200 to 299 are successful responses. 300 to 399 provides redirection information. 400 to 499 are client error responses, and 500 to 599 are server error codes. Server errors are usually raised when the server-side code lacks proper error checks in the code, configuration mismatch, incorrect package dependencies, and so on. The client-side errors usually occur when the client makes a bad API request with insufficient information in the request body, or when the client requests a resource that is not present on the server. But take note that sometimes the same status codes can convey different messages in different contexts. For example, a 200 status code for a GET request means the content was found. The same 200 code for a PUT request means that the data transmission and update process was successful. Similarly, for a delete request, this 200 status code means that the resource was successfully deleted. Some of the most used status codes are 200 and 201, 303 and 304, 400, 401, 403 and 404, as well as 500. You will learn more about what these status codes mean as you move through the course. And that brings you to the end of this HTTP recap video that refreshed your memory about HTTPS, HTTP methods, requests, responses, and status codes. These are the fundamental concepts that you will use to develop sustainable and manageable APIs. Now that you've had a refresher on HTTP and HTTPS, you are ready to learn about REST APIs. But first, you need to know what is REST. In other words, what makes the APIs RESTful? An API, or Application Programming Interface, is a gateway to back-end data. It allows you to easily access and modify this data. And REST is an architectural style for designing APIs for your project. It is hugely popular among developers because it's much easier to develop and implement than other architectural styles. What works in your favor is that the learning curve isn't steep and you can create production-ready APIs in a short time. But let's not jump too far ahead. You're not quite creating APIs yet. Rather, you are first learning about the basics of REST APIs. REST APIs provide an easy way for you to communicate with the server and access the data that powers your application. But an API is only RESTful if it complies with certain constraints. Let's examine them. It must have client-server architecture, a REST API is always stateless, and it should be cacheable. It should be layered, have a uniform interface, and it might also include code on demand, but this is optional. Let's explore each in more detail. The API should use client-server architecture. There should be a server that is serving the resources, and there should be a client who consumes them. A REST API is stateless. This means that the server does not contain any state of the API client who is making the call, so it cannot identify who is making the request or what their previously requested data was without proper user information. In fact, the state is only saved on the client machine, not on the server, and this influences what you should include in your API's endpoints or URL paths, but more on this later. The API should also be cacheable. This means that responses can be saved by a web browser or a server or any system. This caching process can help to reduce the server load by using the API result from the cache, instead of making an actual request to the server every time. Layered means that the entire system architecture can be split or decoupled into multiple layers, and you should be able to add or remove a layer at any time. The following diagram will make this layering more understandable. Layers of a RESTful API system could include a firewall, load balancer, a web server, and a database. Let's move on to the constraint of having a uniform interface. This may sound a little confusing at this point, but it means that the system should offer a uniform communication system to access the resources. For example, there should be unique URLs for each resource. There should also be a unified way to modify or proceed further with a resource from the API result or representation in a standard XML or JSON format. Lastly, code on demand means that the API may deliver some business logic or code that the client can run to further improve the response result. To understand this code on demand feature, consider the following script tag that loads some JavaScript code from an API endpoint of the Little Lemon restaurant. Once loaded, this script can display any special menu items for that day. For now, these 6 constraints are just theoretical. Do not let them confuse you. Once you start developing your APIs, these terms will become clear to you. Next, let's focus on resources. Resources are a core part of every REST API, so it's important for you to become familiar with how APIs present resources. Say the Little Lemon restaurant has a mobile app, which can be used by customers and managers. Managers can use the app to get information about orders and customers, while the customers use this app to browse the menu and place orders. To support this, the app uses different APIs to fetch data from the server, and in each case, the resource type will be different. Let's explore a few examples. If a manager wants to see all orders, the app makes a call to the API little.lemon/orders and displays the result. The resource type in this case is a list of order objects. If a manager wants to view more specific information about a particular order, say the order with the ID 16, the app makes a call to the API little.lemon/orders/16. The resource type is the order object. To see who placed the order, the app makes an API call with an extra filter /customer. This retrieves all the details about the customer of that order. The resource type in this case is the customer object. Say the manager wants to look at what the menu items of order number 16 were. The app makes an API call that replaces /customer with /menu items. Only the menu items of order 16 will show in the result, and this time the resource type is the menu item object. Now, on the other hand, if the customer wants to browse the menu, the app uses another API, little.lemon/menu items. And although the resource type will also be the menu items object, the return will be all available menu items of the restaurant. But sometimes the resource type is the same, although the result can be filtered to be more specific. Let's explore a final API to unpack this. This time, the customer wants to browse food items from a specific category, say appetizers. The app will add category appetizers. Notice that the endpoint is the same as the previous API, but it filters the output to only appetizers. For both cases, however, the resource is still menu item object. Now that you've explored a few examples of API resources, let's revisit the REST API constraint of statelessness. You need to keep in mind that the server always represents only what you ask for. It does not remember anything of what happened before. For instance, if the manager retrieves the information about order 16 and then wants to look at the menu items of order 16, you cannot just send a follow-up HTTP request to the endpoint /menu items, because this API will return all menu items and not just the menu items of order 16. The server does not remember that your earlier call was for a specific order. If you want to get the menu items for a specific order number, you need to explicitly supply that order number to the server as orders/16/menu items. In simple terms, this is what stateless means. The server cannot recognize the client automatically. API calls must include more information about the user, but you will learn more about this later in the course. In this video, you have learned how to create REST APIs by following some key constraints. You also learned about the core parts of REST APIs, like the resource types. These conventions will help you build APIs that are easy to use and maintain, but there is a lot more to learn on how to optimize your APIs. For instance, using the correct naming convention. But more on this in an upcoming video. By now, you know the importance of API endpoints and how they determine precisely what data the server will send to your app. But a well-designed endpoint also conveys valuable information about its purpose, which is helpful for developers and the project itself in the long run. Your REST API's Uniform Resource Identifier, or URI, is one of the first things that users will notice when a page loads. It is also called an endpoint or URL path. First impressions always make a big difference, and that is why naming conventions for APIs are important. This video will help you name your API endpoints for maximum clarity and impact. Let's get started. Say the Little Lemon restaurant menu app needs APIs to display all their orders. A suitable API endpoint is /orders spelled with a lowercase o and not orders spelled with an uppercase O. So, your API endpoint should always use lowercase letters and hyphens to separate multiple words. Using underscores or snake case, title case, or camel case to separate words is not optimal because it makes the names difficult to read and understand. There is an exception to the camel case rule, though. If your API accepts a variable, for example a user ID or order ID, you should always represent them in camel case and wrap them in curly braces. For example, if you want to create an API for a specific order, it should be /orders /open curly brace order ID with a capital I close curly brace. By adding /menu-items to the API endpoint, you can fetch the menu items for a specific order. Or you can fetch orders of a specific customer by changing the ID to customer ID wrapped in curly braces and adding /orders. Notice that the API endpoints contain two different variables, order ID and customer ID, and they are both denoted by wrapping them in curly braces and writing ID with a capital I. Also, always try to use clear, concise, and meaningful words in your API names to make them easy to read right away. Next up, the use of forward slashes. If your project has related objects, you should use forward slashes in your API URIs to indicate their hierarchical relationship. An example of such a hierarchy is, a customer can have orders with order items in a restaurant API project. Another example is, a library can have books with authors, so to get the author of a particular book, you can use the API endpoint library/books/ and then book ID wrapped in curly braces, and finally /author. Or, to get all books written by a particular author, you can use an ID for the author instead and add /books. Notice how the relationships between the customers and orders, the books, and the author are all indicated with the / in these API URIs. Another naming convention is that your API should always use a noun to indicate the resources it is dealing with. An API that returns a collection of books or a book should use the nouns books or books and book ID wrapped in curly braces. Similarly, to get the price of a book, you should use the nouns books, book ID, price. API endpoints with verbs like get all books or get user, user ID are examples of bad API names. That's because the resources in a REST API endpoint should be always represented with a noun and never with a verb. API endpoints such as users, user ID, delete, or orders, order ID, save are also wrong because they use HTTP requests as verbs to indicate the action the API performs. Remember, you should send an HTTP delete request to users, user ID to delete a user, and you should send an HTTP put or patch request to orders, order ID to update the order. Endpoints that use standard CRUD operation names such as create, read, update, or delete should be avoided for two reasons. The resources these endpoints represent should be nouns, and the appropriate HTTP requests like get, post, put, or delete should be used with those endpoints to perform the necessary manipulations. Something else to consider is whether file names should be used in APIs. The Restaurant API project can return API results as XML and JSON data. So the question is, can you design your endpoints as orders, order ID.json to get the JSON data, or perhaps orders, order ID.xml for XML data? No, you should never use a file name extension in your API. To solve this problem, you should accept the expected data format as a query string parameter. So, if you want the output in a JSON format, you can add $format $JSON to the API endpoint. And for XML, you can use $format $XML at the end. Similarly, to deliver a minified version or source version of a JavaScript file, you use API endpoints like /assets /JS /jQuery/3.6.0/min or /assets/JS/moment/2.29.4/original. But what if you need to filter a collection or perform a search? For instance, the Little Lemon restaurant has many items on its menu, but you are only interested in appetizers. To filter the results, you should always accept the data as a query string parameter. In a URL, everything you send after a question mark is a query string. Remember, the API endpoint menu items returns all menu items. But to only get the appetizers, you should pass the category name to the endpoint as category =appetizer. Consequently, if you design APIs that can be filtered this way, other developers on your team will derive that to get a list of mains or desserts, they can change the endpoint to category =main or category =dessert. This is the beauty of a good and consistent API naming strategy. Another best practice is that when you share your API endpoints with your team or the public, you should never add a trailing slash to the end of the API endpoint. What this means is that API names that end with a /, like orders, order ID in curly braces, followed by a /, is bad practice. So is sports, basketball, teams, followed by another / at the end. Simply end the API without the / at the end. So, if you want to become a fluent backend developer, you need to pay attention to your endpoints and make sure you use well-designed and user-friendly APIs. Let's recap the best practices discussed in this video. Use lowercase URI formatting. Indicate hierarchical relationships with a /. Use nouns for resource names. Avoid file name extensions. Furthermore, use query parameters for data types and don't use a trailing slash. Finally, always follow a consistent naming strategy and standard API naming conventions. Well-chosen names for API endpoints can significantly improve an entire project by making it easier for other developers to use your APIs. And now you are well on your way to creating good API endpoint names. If you want to work quickly and efficiently as a developer, you need the right tools. For example, an intelligent code editor can help you develop more rapidly and become more competent. In this video, you will learn about a few command line and graphical tools that you can use to play around with your APIs. You will also explore a practical demonstration of how to test APIs in Insomnia. These tools are a cross-platform, so you can use them on Windows, macOS, and Linux. You will be using some of these tools, like Insomnia, throughout this course, so it's important to learn about them now. Let's get started. First is curl, a well-known tool for developers who want to make HTTP calls from the command line. It is available for all major operating systems, but it doesn't have a graphical tool. To use curl, simply open your PowerShell in Windows or the terminal in Linux or Mac OS, type curl and hit enter. Curl makes it easy to send HTTP GET requests. For example, simply add the API URI after curl. This command sends a HTTP GET request to Postman Echo, a service from Postman, to display the headers and request body sent to it. Pretty useful for testing API calls. It works slightly differently for a POST request. This time, add the request body using -d and the HTTP method name, which is POST, preceded by -x. The second tool is Postman, which has cross-platform desktop tools that make it easy to test and debug APIs. With an advanced graphical interface and a web version, Postman is a powerful tool for API development. With Postman, you spend less time fiddling with API details and more time building the perfect API. You can explore their website in the additional resources for more information and learning materials. Another important tool is the Insomnia REST client, a powerful REST API client used to store, organize, and execute REST API requests. Insomnia is free, cross-platform, and comes with a very user-friendly interface. You can download and install Insomnia for your operating system from the link provided in the additional resources at the end of this lesson. Note that there's only a desktop version for Insomnia. In the rest of this course, you will be using Insomnia to play and interact with the APIs you build. Let's examine how to use it. Insomnia is a great tool for playing with APIs. All requests in Insomnia will be saved in a request collection. To get started, click on the Create button in the top right corner and select Request Collection. Give it a name, like First Collection, and click on Create. Now you are inside an empty collection. To create your first API request, click on the plus icon on the left sidebar and select HTTP request. You can also do this by pressing Command plus N on Mac OS or Control plus N in Windows and Linux. You can double-click on the default request name New Request and change the name to something more personal, like First Request. At the top of the middle section, where it says Get, you can click and select the type of HTTP method your request is going to be. Leave it as GET for now. In the text box next to it, write your API URL https://httpbin.org/get ? project equals Little Lemon. httpbin.org is a free service that allows you to experiment with different types of HTTP methods. When you call one of these APIs, it prints back what you sent to it. Now hit the Send button on the right, and you will see that http://bin has returned the same query argument you sent to it, which, in your case, was project is equal to Little Lemon. This time, let's try making a new HTTP post request. To do this, click on the plus icon in the left sidebar and select HTTP request. Once the request is created, double-click on its name and give it a new name, such as Second Request. Now click on the HTTP method drop-down and select Post, and this time add https://httpbin.org/post in the URL field. You already know that a HTTP post request accepts arguments as form data or JSON data. With Insomnia, you can easily input data for a post request by clicking on the Body tab and selecting Form URL encoded or JSON. Here in this argument window, you can finally lay out all your arguments in an easy-to-use and organized manner. On the left, you can write the argument name, and on the right, the value. Write Project in the argument field and Little Lemon as the value. Now click on the Send button to display the output. You can create as many requests as you want and come back later to play with them anytime. In this video, you learned about great tools such as curl, Postman, and Insomnia that you can use to create and test your APIs. By now, you should know the best practices for developing APIs, but there is another important aspect of APIs to consider: security. The core purpose of APIs is to make your data more accessible, not just for your apps and websites, but also for third-party clients. This way, your data becomes even more useful. But don't forget, because APIs are publicly available, they may pose a risk to your back-end services. Essentially, APIs give third-party apps access to your server and database. That is why it is crucial to secure APIs. This video covers how to keep your API safe and secure. And you'll learn about various security concepts and how to implement them in your own APIs. First up is SSL, or Secure Socket Layer. SSL encrypts your data and protects your data when it leaves your browser and the web server. When you set up the SSL certificates properly, your APIs can be served over HTTPS. The front-end and mobile application team that works on the Little Lemon project want to ensure that the data is transported securely. So, the API team has used SSL certificates from a reputed provider and installed them. Now all the API endpoints are secured and serve data over HTTPS instead of HTTP. That's why it's important to always check that the endpoint of your APIs starts with HTTPS instead of HTTP. Next is signed URLs. The Little Lemon project team wants to ensure that the API calls are coming to it from their mobile application and their website only. This is where signed URLs come in. Signed URLs give a client application limited access to a specific resource for a brief period of time. With a signed URL, every time an API is called, a particular piece of text called a signature is included with the URL. Server-side code can verify the signature and ensure that the call comes from an authentic source. But how do developers create these signatures? HMAC is a popular signing mechanism used by modern applications. It is easy to use and ensures the authenticity and integrity of the message. For example, some secret message, encoded by a digest algorithm with a secret key, some secret key, creates this HMAC signature. Next, let's discuss authentication. All of us are familiar with usernames and password-based authentication, but sending a username and password to every API call is frustrating, and it's not secure. So, the Little Lemon team prefers using token-based authentication over HTTP-based authentication when securing its API, because basic authentication requires users to send their username and password in every call. With token-based authentication, the user sends their username and password to the sign-in URL and then receives a unique token in text form. After that, every API call will include this token as a HTTP header. The server-side code can check the token, extract the information hidden in it, and match it with an existing user. After this verification, the rest of the work is performed on behalf of that matching user. To create this token, you can use an ad hoc policy from the back-end framework you're using, or you can use something more industry standard like JSON Web Token or JWT. You will learn more about this later in the course. Next, you need to know that there are a couple of popular HTTP codes involved during the authentication process that you should be aware of. 401 means unauthorized. In this context, unauthorized means the username and password don't match, so the server cannot continue further. And then there is 403, which means forbidden. This is an interesting code, and it means that your credentials are valid and you have successfully identified yourself, but you don't have the authority to perform the action. Last is the cross-origin resource sharing or CORS policy and firewalls. When you design an API, you can accept calls from everywhere, or by configuring the CORS headers, you can only accept calls from some specific domains. And finally, another security measure that you can use is firewalls. If you want to ensure that only specific IP addresses can access your API, you can use a firewall application on your server. In this video, you have learned how to protect your APIs. Security is an important consideration when designing APIs, and you are now better positioned to protect your infrastructure and keep your user data safe and secure. Creating a REST API is straightforward, but to make it robust, reliable, and perform well under loads, you need to spend time planning the architecture. And that's where this video comes in, because you will learn about REST's essential best practices that every API developer should know. First is KISS, which stands for Keep It Simple, Stupid. What this means is that you shouldn't try to perform too many tasks with one API. A single API should do one specific job and do it well. For example, for the Little Lemon project, the manager needs to update the item of the day, and you want to make this easier for him by creating a new API. One approach is to let the API determine what the previous item of the day was, and to remove that status from the item. And then it has to randomly pick one item based on some criteria and set its status as the new item of the day. But this is asking the API to do too many things. And if you randomly pick an item, it might not actually be the most popular item that day, right? A better approach is to create only one API which updates the menu item. Now, when the manager updates the item of the day, a HTTP patch or put call is sent to the API to set the status of the previous item of the day to off. Say item 16 is the item of the day. The API for such a call would be menu items /16 with a HTTP request body with a status set to off. The manager then manually selects a new item of the day, which makes another API call to update its status. A put or patch request is sent to menu items /21 with a status parameter set to on in the HTTP request body. The new item of the day is now item 21. This way, there will be no chance of accidentally selecting the wrong menu item as the item of the day, and you're keeping your API endpoints simple and focused. The next best practice is that you should always provide a way to filter large result sets and rearrange them in ascending or descending order. Using pagination, you can deliver results in smaller chunks. For example, the API /menu items returns all available menu items at once, but a customer may want to see only the desserts.